this volume, your first step is you've got to form the right integral. Okay, you've got to form the right integral. So let's just remember, not that it's the important part that gets you marks, but what is the general formula for the volume of a solid of revolution? How do you form it? You start with your pi, right? Times the integral of, and then you stick in whatever boundaries. Okay. Now what's the integrand? It's y squared, right? And it's with respect to x, and you can know because that's the way you're rotating. Okay. So that's the way I think about it, because if you want x squared dy, then you go the other way. Okay. Now, if that's our setup, okay, we can substitute in the right things that are relevant to our question. So let's try that, right? So the volume is equal to pi. What are our boundaries? 0 to pi on 4. Now, watch out. I've seen a couple of you make this error. It's 1 plus tan x, right? So clearly you can see if I'd just taken regular tan x, right, I wouldn't quite get this shape, because tan x goes through the origin. So I'd get a pointy thing, right? I wouldn't have a nice flat surface there, okay, because you just have that, and that would be what's rotated, okay? So therefore you have to account for that in your integral. This is 1 plus tan x, all squared, okay? All squared, vitally important, right? We spent some time looking at why you can't just square bits individually, but anyway. All right, so then you can expand that out, even though you might be tempted to think, oh, is there any reverse chain rule business here? But actually, expanding will let us use some identities that we know, right? So the expansion, of course, is 1 plus 2 tan x plus tan squared, okay? And that's going to be useful to us in a second, all right? So what's your first identity that you can use to work with this? 1 plus tan squared, what's it equal to again? Is it sec squared, or is tan squared equal to sec squared plus 1? Which one is it? How can you be sure? Go back to this. Always come back to this, right? Because we can reliably get this right, whereas under exams we can muddle this up, and I've seen some of you do exactly that, okay? So I guess what would you do to this? You'd divide everything by cos squared, wouldn't you? Okay, so you can see that 1 plus tan squared, that's going to result in that. Okay. Way of remembering it?
Yeah.
Do I dare ask? Or did it work?
Yes.
How did you do it?
I remember that.
Should I finish my explanation first and then you can tell me? Okay, fine. Alright. Now you look at this, sec squared, you know how to integrate, right? What does it integrate into? That'll become tan, right? But 2 tan x, what do we do with that? Okay, do you remember? Now, because it's sine over cos, right? Let's think about this on the side. If this is all I have to worry about, okay? This is almost f dash on f, isn't it? It's not quite though. What would I have to do to make it f dash on f? I need a negative in there. And I'll slap one at the front just to make sure. Okay. So seeing as it's f dash on f, what is the integral? It's log of f, right? Don't forget the minus sign. Okay, so that's what we would have if we just had regular tan on its own. Now we've got 2 of them, so no big deal. I'll just double it. From 0 to pi on 4. There you go. I think that's the hard work. But for the sake of it, we can evaluate this, right? So I'm going to draw a new column for myself. Okay, so let's do this. Don't forget your pi at the front, please. It's an easy thing to just disappear, right? What do I got here? Tan of pi on 4? Yeah. Minus 2 log cos pi on 4. Now there's a lot of simplifying you can do in here, okay? When you actually evaluate it, even though it looks awful right now, okay? What's the other boundary? Now, you look at it, right? I know a lot of it's going to vanish, but you can't not write it, okay? You have to show that you understand what this means, so that's why you've got to evaluate the pieces, okay? Even if they do end up being trivial. So you got tan 0 minus 2 log cos 0. There you go. Okay. Happy? Is that right? Let's start evaluating. Tan pi on 4? 1. Cos pi on 4. 1 on root 2, yeah? 1 on root 2. Okay, think about that. Come back to it in a second. Tan 0, 0. 2 log of 1. Log 1 is just 0. Okay, great, that's good. Now, that 1, not much to do with it, right? But 1 over root 2, it'll help us if we can write this in index form, right? Why? Why am I immediately going to index form? Because you've got log laws that can work in here to simplify things, right? So this is 2 log what? 2 to the power of? Negative a half. The half is the square root and the negative is the fraction, okay? And you can see what's going to happen here, right? This is going to come out the front and it's going to exactly cancel. In fact, the negative is going to cancel and the 2 is going to cancel, so you'll get that. Yeah? Okay, so therefore, the volume is, and then you can slap your units on.